want to solve x squared plus 9 equal to 0 kinds of equations. These are second order for one unknown equation. And when we simply solve this equation, there is a method: knowns one side, unknowns one side. After that, we ask by ourselves to which x enable minus 9 when we take square of that. And there is no such kinds of number. No number, but for real numbers we talked. You know, this is number line, which composes with infinitely many points. If you take these points at a set, and such as there are infinitely many numbers, and all of them is real numbers. So we can say for number line, for example, for other name, real number line. And when you look at this equation and you say no numbers for solution of this equation, you want to say solution set is empty for real number line. There is no point on real number line which enable a solution for this kinds of equation. But if with a bit difference, for example, such kinds of equation can be solved from Middle Ages, or we can say we have be able to solve this kinds of equation for years since Middle Ages. And x squared knowns one side, unknown one side, and which number square is 9? You can say 3 simply. And then I ask, think a bit, is there any other? You can think minus 3 also, because square of both of them is plus 9. x1 and x2. Solution set has two elements, minus 3 and plus 3. And these are real numbers. From real number line, we can say plus 3 is there, minus 3 is there. And then simply we can say this. In 19th century, these kinds of equations, x squared equal to minus 9 kinds of equations, very popular to study for many mathematicians, and especially earlier want to solve and want to use these kinds of equations. Then find a new method or find a new idea about this issue. He wanted to take both sides square root and find such kinds of expression. Is this a number? We can say now this is not a real number, so there is no place for on real number line for these kinds of numbers, but outside of the number line can be perhaps. But firstly, we should write these numbers such as square root of minus 9, square root of 9. Square root of minus 9 can be set I. Square root of 9 is, 3. Why we set this I? Because imaginary is I. But Euler decided to say that expression I because he should write again and again same expression. Then he decided to give a sign to express this equation. You can say now 3i is a solution for these kinds of equations, but this solution is not on the real number line. This is different kinds of thing. And after a bit think, you can say minus 3i also can be set. Enable this equation. These are roots for solution set, plus 3i and minus 3i. Now we know real number line, and there is no place for this kinds of equation on real number line. We also know about coordinate system, x and y axis. Then 1, 2, 3 numbers, plus numbers, minus 1, minus 2, minus 3, minus numbers, I, 2i, 3i, 4i, and minus I, minus 2i, minus 3i kinds of numbers. Then if we express numbers such as, then 3i here and minus 3i at here, outside of the number line, and there is a place for them. This is a plane, two-dimension kinds of place. And if we talk about a bit more, for example, this point 3, comma 1 kinds of, this is a ordered pair. Also we can say, for example, 2, comma minus 2, and we should find an expression, a standardized expression for these kinds of numbers, and we use mathematicians at 19th century use this expression, such as this is real part, this is imaginary part, and now or numbers, for example, z1, 3i, 0 plus 3i kinds of real part 0 and imaginary part 3, z2 minus 3i, 0 minus 3i, real part 0, imaginary part 3, z3, z3 can be that, 3 plus 1i, 3 plus I, z4 that, 2 minus 2i, you can say real part 2, imaginary part minus 2. Of course, you can say, for example, this is a number on coordinate plane, and you can say 3 minus, comma 0 ordered pair. Then z5, that is z5. For z5, for example, 3 plus 0 multiple I, you can say, and 0, 3 z5. This is a real number. Also can be written as a complex, these kinds of new numbers. Now we find a standardized expression, these kinds of numbers. There is a new issue for mathematicians. Real numbers, subset of these new number set. There is infinitely many new numbers and a new expression and new a new plane to find places for these kinds of numbers. Real numbers, also such kinds of numbers. The name of this number set, complex numbers, and the sign is C.